Right, guys, welcome back. It's good to be back with you. We've had quite a few people posting things during the week. We also had some questions about electricity. So let's make sure that we've got the electricity section sorted out. Today we're picking up some questions from the previous exam papers. So let's make sure you're right on track with those. So here we go. We're going to take a look at question number 9 from the Gauteng Department of Education prelim, and it's a circuit question. So if we've got it here, we're told the battery in the circuit diagram, which we're coming to in a minute, has an EMF of 30 volts, an unknown internal resistance little r. So we know that there is an internal resistance. There's the 30 volts. We don't know what the internal resistance is. That's an unknown. The resistance of the ammeter and the connecting wires is negligible. Remember, that means that R is equal to 0 ohms. We are going to assume that there is nothing. So let's look at the circuit. And if we start at the positive, now remember that the larger terminal is the positive. And if we go around here, we've got an ammeter connected in series. This is reading the total current. Then it divides. So notice that at that point, there is a parallel branch. So in this part of the circuit is one branch, and I'm going to just label that branch or color it as being the pink branch. It joins back over here. So it looks to me, just by looking over here, that here's the main part of where it joins again. In the second branch of the circuit, all of this area here, this is in the second branch. So we've identified that we've got resistor 1 that's in parallel with resistor 2, which is in series with resistor 3. So let me just change my coloring so that we've got this one in pink. So we do identify. Okay, so that's in, these ones are in series, but they're in parallel with this one. The voltmeter reading here is reading the potential difference across the branch, either of that one, from there to there, or in fact we know it's the same if it was there, or it was there, or it was there. So that voltmeter is the second reading. Voltmeters in parallel. Notice the first voltmeter is connected also in parallel, and it's connected across the battery between that point and that point. Now, the biggest feature on this diagram is there. We've got a switch, and the switch is open at this stage. If you've got an open circuit, then no charges can flow. That means that the current reading on the ammeter will be 0. So this, at the moment, with the switch open, is going to be 0 amps. But the voltmeter reading here is going to read the EMF. No work is being done in the external circuit. So that's the first question. With the switches open, what is the reading on the voltmeter? The way I like to explain this is the following. If the battery isn't doing any work, then we're measuring its maximum potential. As soon as you start to make it work, you've got to push the charges from the negative terminal through to the positive terminal if we're talking about positive charges. So there's work done inside the battery as well as outside the battery. But when we've got an open circuit, no work is being done. So when we close the switch, we know that there's going to be a change because the voltmeter now will only read the work done external in the circuit. So at this stage, we know that it's only reading the EMF, and we say the voltmeter V1 reads the EMF, just so that you are clear about the reasoning for that. We're going to say this one, V1, is going to be equal to the EMF, and we were given the EMF of 30 volts. We can put here EMF, and the reason no work is done, there's an open switch, there's an incomplete circuit, okay? No work is done, external or internal circuit. Okay, let's move on. Second question. Now, this is a favorite type of question. Calculate the total resistance of the external circuit. Now, remember we set it up just now, and we marked this one as pink, and this part here is the parallel section. We've only got the parallel section, no other resistor. So really what we're asked to do is an easy calculation. Calculate what the equivalent resistance is, and we're going to use the formula that says R parallel, 1 over R parallel is equal to the resistance in branch 1, which I did as the pink branch. So let me just make sure that this is the pink branch, plus the resistance in branch 2, which is the orange branch. So what do we know about branch 1? Well, branch 1, there was only the 50 ohm resistor. So that's 1 over 50. Now, what do we know about what's happening in branch 2? Well, branch 2, we've got 10 ohm and a 30 ohm. How are they connected? Well, they're connected in series, one after each other. So the first thing I'm going to do is just a little bit to the side here. I'm going to say resistance of branch 2 is equal to R2 plus R3. We're just going to add them up. 10 ohm plus 30 ohm. And that's going to give me 40 ohm of resistance. So got R2, going to say 1 over 40. Now guys, here's the tricky bit, but it's not really that tricky. We're going to need to find a common factor here between the 10 and the 50 and the 40, and I reckon that the closest one that I can see is 200. 50 goes into 200 4 times. 40 goes into 200 8 times. So that gives me 12 over 200. Let's put up the calculator and make sure we've got it right. So we're going to say use the function on the calculator that gives us these nice fractions, 1 over 50, and then we go there, plus 1 over 40 equals, and it's 9 over 200. I've made a mistake somewhere. 54 times 40, I can't see it, but we'll believe the calculator. Must be 5 times. That's it. It's not 8, it's 5 times. So 8 over 200. And now we know that what we've got is 9 over 200 is the correct answer. Let's just complete this. Just make that 5, which means that we've got the answer of 9 over 200. But remember, this is 1 over R parallel. So what we want is R parallel. We want R parallel. Now here's the shortcut that I use. When I get an answer like this, I push that button and I get 9 over 200, which is just inverted. And I say, well, give me that answer. And it therefore says to me, it's 22,22. And where we go, therefore, R parallel is 22,22 ohms. Excellent. And we're sorted in terms of getting that equivalent resistance. Make sure that we've got, that's exactly what we were saying. Just want to check that we've used all the information that we need. We wanted the total resistance of the external circuit, and we've got that all those readings in place. So let's just make absolutely sure that we are going to use that one in the next calculation, and we'll go to it now. So it says that we've got V2 is equal to 24 volts. So now guys, look here. This is the potential difference across the parallel branch. And what we're asked to do is to calculate the internal resistance of the battery. So when we're looking at the internal resistance, the first step that you've usually got to make is to calculate the current in the circuit, the maximum current. And we're in a position to do that right now because we recognize in the external circuit, there's only one real source of resistance, and that's there. We've calculated that resistance. We know the potential difference across that resistance. So we know R external is equal to 22.22 ohms, and we recognize that the potential difference was 28.4 volts. So this was across the parallel. This was V2. And what do we know? I is equal to V over R. And so we can get the current. Not difficult to do that. 28.4 divided by 22.2, and here we go with it. Clear that for a minute. 24.4 divided by 22.2, and we're going to get a current of 1.099. Rounded off to 2 decimal places, and I'm going to say that the current is 1, actually, I'll keep that current on there, but I'll write it down as 1.10. So I'll keep it on the calculator. I know I'm going to use it, but let me write it down as 1.10 amps. Might even be easier to work with that, but if I want the internal resistance accurately, then I'm going to need to use that. I is equal to R plus little r, and here we go. We're almost there. We've almost got it. I don't think there's too much of a problem. We know that the original was 30. That was given in the question way back there. We know that the current is 1.10. We know that this is 22.2. And we don't know the little r. So let's find it. And it's not it's just a bit of a calculation to go through. So let's do it on the calculator. We're going to say that 1.1 times 22.222 gives us the IR value. So let me write that down. 4.42. 24.42 plus 1.10R is equal to 30. And now we can find the difference between that value and the 30 and then divide to get to change the subject of the formula. So if I've got this value, I want to now make it a negative. So I'm going to just times it by -1 just as a shortcut. And I'm going to add 30 to it. And then I'm going to divide by 1.1 to get my answer for the internal resistance. And there I have it. My answer that I got, rearranging the subject of the formula, 5, now I must do to 2 decimal places, 5,07. So let's write it down, 5,07 ohms. Okay, let's just make sure that we've got that right. We're going to go to a short break. After that, we'll pick it up and finish this question.